Okay, for number 17 here is probably most helpful just to give a quick sketch here and making sure we do it right. So we're going to draw a triangle LKQ. Doesn't really matter what we draw here. LKQ. And then we're going to draw a similar looking triangle. And we have to make sure we keep our corresponding pieces the same here. So L goes with X, so that's up on top. K goes with R. And Q goes with P. So now we're in a position to do this. So let's remind ourselves what corresponds here. Those correspond, and then K corresponds with R. Okay, so angle L will definitely correspond with angle X here. So A is not right. Angle K will correspond with angle R. So that one is definitely true. LK over XR, so those are corresponding sides, equals KQ over here over XP. That's not going to be true because those are not corresponding sides. So LK is a corresponding, so this part would be okay, but KQ should correspond with RP and not XP, so that one's not true. And then the last one is LQ over XP. Those are corresponding sides. KQ over RP, also corresponding sides and in the right order. So that one's also true. So the answer to this one is B and D. Okay, this first one, we just need to see if all the angles are the same. So it's hard to exactly tell here, but if you solve for this angle by knowing that they all had to add up to 180, this would be 65. This would be 30.4, and so because two corresponding angles are congruent by AA, this one will be similar. So the answer to that answer is true. Here, these are you can think of these as three triangles. We have a little one here, a bigger one, and an even bigger one. All of them have this angle that's the same. All of them also have a right angle, and so because they each have two angles that are the same by AA, they are also all similar. So the B is true. C, these are all isosceles triangles, but they don't have all the angles the same. So right, if that's the true, you know they're not similar. All similar figures always have angles that are the same. In D here, so for D here, we can see that one angle is definitely going to be the same because those are vertical angles. We know nothing about those, so AA is not going to help us here. It's three sides, we don't have that third side, so we're not able to check whether three sides are proportionate. And then the other one we could use is SAS. We have a side and an angle here, but we don't have another side. So the two sides that we don't have the included angle, so we're not able to use SAS, so we're not able to conclude that these are similar because the three AA, SSS, or SAS will not help us out here. For E, because of vertical angles, we know we have an angle here that's congruent, and so we don't have two other angles, so we can't use AA. That doesn't help us here. We don't have three sides. That doesn't help us here. But we do have a side angle side, so we have to decide if we can see if corresponding sides are proportionate. So we can check, does 2 over 1 equal 8 over 4? Well, that's true. Now you might have been tempted to say, ooh, should we check 2 over 4? Does that equal 8 over 1? That wouldn't have been true. And you need to check that, but you have to check all possible correspondences. So we could have tried that first, but we have to try the other combination too. And if we find one that works, then we know they're similar. So this would have, this vertex would be similar to this vertex. This vertex would be similar to this vertex, and then there. So it's a kind of a turned around triangle. So anyway, we were able to prove this one by SAS. This one, if we solve for the angles, we get 31 over here, 21 over here, since all the angles are not the same, not similar. In G here we don't know anything about the angles, so AA doesn't work. Same for the same reason SAS can't help us. But we do have 3 sides, so we have to check whether corresponding sides are proportionate. So instead of checking all the possibilities, if it's gonna work, the smallest side should be proportionate, will correspond to the small side of this triangle. So we're trying to test whether 10, so I'm going to go in this direction here. So this 10 over 18, is that equal to 15 over 27? That's the middle value for each one. And then 20 over 36. So we're going to have to reduce these fractions to see if they're equal. 10 over 18 is 5 over 9. I can divide 3 out of each of these, so 15 divided by 3 is 5, 27 divided by 3 is 9, and then the same thing here. There's a common factor of 4, 20 divided by 4 is 5, 36 divided by 4 is 9. Because I get the same scale factor for all 3 correspondences, I know that they are similar by SSS. If by some chance 2 of them were the same and 1 was different, it would not be similar. In order to be similar, all 3 of them have to be proportionate. Then the final one here, we have vertical angles are congruent. These are parallel lines, so we also know that alternate interior angles are congruent, and we can do the same thing here. Well, we have 2 triangles where all the angles are the same, so by AA, they are in fact similar. Sometimes with these problems, I think it's most helpful to redraw them. So if we're going to see why they're similar, so I'm going to draw the smallest one, which is 6 and 8, are those 2 sides. And if I draw the bigger one, this side is actually, you got to add those together, 6 plus 4, so that's 10. And the bottom side here is X. And then what do we know about them? Well, we know that these 2 angles are congruent because they are the same angle in the triangle. And then because this bottom segments of each of the triangles are parallel, we know that corresponding same side angles cut by a transversal, so I'll draw it up here in the diagram, we know that this angle has to be congruent to this angle, and this angle is congruent to that angle, because they're parallel lines cut by a transversal. And so in this diagram we know that these angles are all congruent. So the angle postulate is what's going to give it. So it's definitely not these 2 because those are the wrong ones. And then we just need to find X. So we can use our proportions here. 6 scales up to 10, so 6 divided by 10 is going to equal 8. 8 scales up to X. So we can just do our cross multiply here. 6x equals 8 times 10. X equals 80 over 6. And I can divide, there's a common factor of 2 for sure, so 40 divided by 3. 40 is not divisible by 3, so this is the most reduced it can be. And so our answer here is B. So here I've drawn the diagram. Again, important to make sure that you get the correspondence right when you draw it. So here I've drawn P, A, T, and written, because F is written here first, just around the triangle here, F, E, M. So those are corresponding. Fill in the lengths that are provided, 5, 6, and 7. So again, to find the scale factor, we're trying to find a corresponding side where there's both numbers given. So we know that 5 turns into 8. So 5 over 8 is going to be one thing, and then we know that 7 turns into X. So 7 over X. And now we can just solve this proportion. 5x equals 56, 8 times 7, so x equals 56 over 5, which is the answer. So we have 2 similar triangles. We know that 5x turns into 5, so I'm going to write that ratio, and 4 scales over to x, so 4 is going to be x, and now we just have to solve this proportion here. 5x times x equals 5 times 4. Again, x times x is x squared. Don't make the mistake of calling that 6x here. So this is 5x squared equals 20. X squared equals 4 by dividing each of those by 5. So x equals plus or minus the square root of 4. So x equals plus or minus 2. But in this case, we're going to throw out the minus sign because it makes no sense to have a negative distance. So we're just going to use the solution x equals 2 for this one. And now we plug that back in. So x here is going to be 2. 5x is 10. So AB is 10. EF is 2. The answer is B.